Alrighty folks, this is your demo for today's assignment, taking known roots and forming a standard form equation from those roots. To do this, we're going to use our roots form equation. You may recall this is our f of x is equal to a, our coefficient, times x minus p times x minus q, where p and q are our two roots. So plug in what we know, and we have our x minus 4 and our x minus 7. Now you can have any value you want for your a value. This problem only cares about those two roots. So if you want to have an a value that's 1, go for it. If you want an a value that's 12, -5, -1,000, 1/4, whatever you want to have for the a value, go for it. I want to keep this simple, so I'm going to just have my a value of 1. Now that 1, when it comes time to distribute, well, that 1's not going to do anything, so I'm going to ignore it from here on out, because multiplication by 1 doesn't do anything. So we have our two roots set up. Now we FOIL this stuff, so x times x gives us x squared. Outer terms, x times -7, -7x. Inner terms, -4 times x. And then last terms gives us a positive 28. We can combine these middle terms here to give us at the end x squared minus 11x plus 28. And so that is a parabola that has the roots of 4 and 7. Number 2, we're going to do the same thing, or in the second demo, we're going to do the same thing, except now with imaginary roots. We're going to start off with our basic equation. F of x is equal to our a value, and it looks like a q, our a value, x minus p times x minus q. We're going to plug in our two roots, our -3i and our positive 3i. And again, folks, I'm going to have my a value set as 1, so I don't need to put it down because multiplying by 1 doesn't do anything. So x minus a -3i times our x minus 3i. Now, over here I've got my minus -3i. When we subtract a negative, that's the same as adding a positive. So in a way, this is going to be x plus 3i. All right, we got our thing set up. Time to multiply. X times x is x squared. X times -3i is going to be -3ix. 3i times x, positive 3ix. Last terms, positive 3i times -3i, -9i squared. But that I squared, that has the same effect as being a -1. So I can rewrite that such that I have x squared minus 3ix plus 3ix plus 9. And then if I look at my middle terms, well, my -3ix and my positive 3ix will cancel out, which will give me my final answer of x squared plus 9. Essentially, when we have the roots being equal and opposite, that is, say, same number but different sign, our middle terms will always cancel out. That, folks, is the demo for today's assignment. If you've got any questions on them, please ask during class, tutoring times, flex times, so on and so forth. Some of these are going to look a little weird. Number 1 will look fairly normal, but numbers 2 and 3 will look a little weird. Don't worry about it. If you're not sure about the math, call me over before you submit it. Bye.